All right. How's everybody doing? Good. You wanted what?
A motorcycle.
A motor? Oh man, I'm so scared of motorcycles. Okay. Oh boy, why is this not starting? There we go. Okay. So today, well, I don't know. I have some just a little bit more SQL, but before I get started, I just want to check in with you guys. How are your projects coming along? Okay. Some of you have come to office hours, and I hope your visits were at least kind of helpful. And you know, I am curious to hear about your other stuff. I'm wondering, I don't know, maybe for the future, if I should require each group have a meeting with me, but I don't know. We'll see. Okay. We'll take a look some more at SQL and our Chinook database. So I'll go ahead. Yeah, we'll just start everything up. Okay, so we'll import pandas and SQL Alchemy, and then basically all we need is to create an engine. We load up the database, or you know, depending on what your company does or whatever, wherever you got your data, this part will be some kind of connection to some kind of database. So it might not be a local file. Most likely it'll be on some database server, and they'll have whatever the path to connect to the database. Okay, so anyway, we've connected, and here we're gonna just kind of play around with some of these tables, and so just just so you can kind of see what's in each table, like the album table has the album names and artist ID and things like that. One of the kind of principles of SQL is that tables should not contain redundant information. And so rather than having each album then have the artist's name, they instead will have a table of just albums and then a table of artists, okay? And the principle behind it is that if you had the album and then the artist name here, some person might like capitalize things differently, and then you'll have different entries for right, like Alice in Chains, maybe the in might be capitalized or lowercase or something, and then if Alice in Chains wrote multiple albums, you might have slightly differing information from for each row. And so kind of one of the principles of, as far as SQL databases go, is that these things should not be duplicated, and instead you identify things solely by like an ID, a key, and then you would then look that up in the artist table, and Alice in Chains only exists as one row in the artist table. So there's a minimization of kind of redundancy. Okay, so anyway, here's like the taking a peek at the invoice table, okay? And so the invoice would be like an order that a customer made, okay? Here on January 1st, 2009. This is the street, Theodor-Heuss-Straße in Stuttgart in Germany. And anyway, they ordered 2 songs for a total of $1.98, because if I go to the invoice line, and so you can see the kind of the minimization. And so this invoice line has the invoice ID, like these two, 1 and 1, corresponding here, and this person ordered track 2 and track 4, and we would have to go to the track table to find out what track 2 and track 4 is. So track 2 is Balls to the Wall, and 4 is Restless and Wild from, I don't know what this is, but okay. And we have the album ID, and the album would then give us the artist and all of that stuff. And so if we want information from multiple tables, we got to kind of like join all of these things together. So anyway, here I just copied some examples that I found online dealing with the database. But so here is provide a query showing the invoices of customers who are from Brazil. The resulting table should show the customer's full name, invoice ID, date and invoice, and billing country. Okay, so here's a few things. So select is going to give you the columns that you're choosing here, okay? And I guess, SQL is not case sensitive. So we wrote first name just all lowercase, but I guess the true column is first and name is capitalized like that. Okay, so here's a few things you can do. Is the customer table, you can just rename it. You can give it an alias. So rather than having to say first name from the customer table, right? So if we're going to look at, so when we go to the customer, I haven't even looked at the customer table. Let me just copy this, and we're going to take a look at the customer table. Okay, so we're just going to select people, and we just want where the country is Brazil. Okay, so we're going to do we're going to join the customer table with the invoice table, because that's what we want. We want the combination of all the invoices of customers who are from Brazil. So we can get all the customers who are from Brazil just by doing select first name, last name, where country is equal to Brazil. But if we want the invoices and the customers where we're getting kind of this duplicate information, then we have to join the customer with the invoice. And so I'm going to take the customer table, I'm going to give it an alias C, okay? And that way, when I say I want the first name and last name columns from the customer table, I don't have to full type out customer. I can just write C, okay? So we say from customer as C, and then we say we join this on invoice as I, okay? And so we've got the customer and invoice table, and the way we match this up is by using the customer ID here, which are just numbers, and we match that to the on the invoice table. Each invoice has a customer ID, and so it gets matched there. Okay, and so we do that, and then we give it kind of our conditional here. So we want where country is equal to Brazil, and then we say and we specify the columns that we want. Okay. If you comments in SQL are done with a double dash at the, so you can say this selects the desired columns, and then customer as C. So we can say provide an alias to the table, so we don't have to type the full name out. Okay, and then this is how the tables are linked. Okay, so we match the customer ID from the customer table to the customer ID in the invoice table. Okay, and then this is just limits how many rows we get back. Okay, and so this is what we have. Is that good? You have a unique, okay? So a unique list of billing countries. So here we can just go to the from the invoice table. We're going to do select distinct, and then that just gets you all the unique values here. Okay. Okay. So here it says, provide a query that shows the invoices associated with each sales agent. Okay, the resulting table should include the sales agent's full name. So, so this is a little bit tricky, right? So we're gonna go. We're gonna look at basically each invoice. Okay, and each invoice has a customer and wait, what am I doing? Invoices I see as customer. Okay. Oh, and then so each invoice has a customer. So the and then each customer has a support rep. Okay, so we can't get the employee, the support rep, directly from the invoice. We have to kind of link from the invoice to the customer, and each customer has a support rep. So maybe I'll, okay. Each invoice has a customer. Each customer has a support rep, okay, which is an employee. All right, so so in order to do this, we're going to start. It doesn't. We could go either way, okay. But here we started off as join customers to the invoice, okay, and then we're going to join that the customers to the match the employee ID to the customer table support rep ID, okay. You know, maybe this will be easier to understand this way. Okay, so we're going to start with our invoice table, and I think this will still work. Yep. Okay, so we'll start off with our invoice table. We join the invoice table to our customer table, and then we join that to our employee table. Okay, and so we say the customer ID in the invoice gets matched to the customer ID in the customer table, and then we match the within the customer. Each customer has a single customer support rep associated with them, and we match the support rep ID to the employee ID here. Okay, and so we're joining across three tables. So we kind of join our tables here in the from part, and then once we do that, we can then select the columns that we want. So here we're selecting employee first name, employee last name, and then from the invoice, basically everything from there. You can also just do I.star, okay, and this will pull basically all the employee first and last name, and all columns from invoice table. Okay, and then this is kind of how we've joined our tables together, and this is how we've sorted them. Okay, and here it says order by employee ID, and we didn't even include that here, but you can it can figure it out here. Okay, so here's this one. These get a little bit more complicated. Okay, provide a query that shows invoice total, customer name, country, and sales agent for all invoices and customers. Okay, so here again we're going to join the employee table to the customer table using the employee and the customer support rep, and then we join the customer ID to the invoice table, the customer table to the invoice table. Okay, so you kind of need to kind of make sure all of these things join up properly, and then from here all we've done is just kind of given aliases to all of these things. So we've got we have all of this here together. First, last, customer name. Okay, and apparently we have 412 values in our invoice table. Okay, if you need to calculate some kind of summary information, you can basically tell SQL rather than just a single column, you can give it an aggregate command like count or sum. Okay, and so here we're going to select everything for the year 2011. Okay, so we're going to select everything from January to December. Maybe I want this. Will that work? Okay, yeah. So you can just, we can delete the timestamp also. Okay. So this specifies the date range. Okay, and if I didn't do this and I did just invoice ID, invoice ID. Okay. Oh. Wait, what just happened there? So if I just say I want the invoice ID, select from invoice. What am I doing? I just want to show that you can I just want all the invoices with this. What am I doing wrong? Invoice ID. Okay. So these are all the invoices that we have. There's 83 of them. Okay, and we could say, you know, kind of the so instead of doing invoice ID, you can say just aggregate them using count. Okay, and then that will just tell you you've got 83. So let me just okay, so this has a result has 83 rows. And then over here, I want the count and the total sales. So invoice.total. Count and sum of I.total. Okay, so here I've got the invoice ID and then the sum of all of these things. I guess I can just do invoice ID and total. All right, and so if we sum all these up, we get 469.58, and then again you can, because when you run it, they give you just exactly what you've written, and because that's kind of ugly, you can just say count. You can give them aliases as well. And this is a little bit easier. So you have the ability to aggregate things, right? Yes.
If you select both an aggregate amount, like the count of invoice ID, and then just all the unique invoice IDs, will it let you do that if it's like 83 rows and then one row? Would you just have one of the columns with empty rows?
I'm sorry. So
if you were to select count of invoice ID and just every invoice ID as one query,
yeah.
So you get two columns. One would have the aggregate with just one row with the value in it.
Let's see. I think so. Count invoice ID and then just count invoice ID.
And then just to get every like 83 rows, will it let you do
Let me see.
An aggregate and unique values?
It does not. It just gives you the last number, I think. It just gives you the last invoice ID of the thing. What you can do is you can do here it would be a group by, and then you do invoice ID, and group by is 2 words. What did I do? Doesn't like it. From syntax error. Group by I invoice ID. That was the what am I doing? Select, count this. Oh, I have a semicolon that says it's the end of the line. Okay. Darn semicolons. Okay. And so here, when you say group by the invoice ID, you're going to get a count of 1 for every single thing, which, I mean, is correct, but probably not useful. Okay. But it would be useful if you're doing something like if we go to the invoice line table, if I select everything from the invoice line table, then we can group by. Okay, select. If I just say select star, maybe I only want like 20. All right, let's just limit ourselves to the first 10 rows. Okay, so the invoice lines, you've got multiple lines per invoice. Okay, so this invoice 2 had 4 tracks associated with it, and so here you can select the invoice ID and the count as count, and then it'll say invoice ID number 2 had 4 tracks associated with it. Yeah.
This isn't related to the question you were doing, but this is a question I got and I didn't know how to do.
Okay.
How would you that you listed out the counts get, like, for example, the minimum and the maximum count?
Yeah, so when you do the group by, then you can set the conditional, and you can say having count greater than 2, or like greater than 5, okay? And then here, then you can set a conditional. Is that what you're talking about?
I was wondering more of like how to get the maximum count and the minimum count from that data table without like looking at the data. Let's say like it's gonna change, and you just want you want 2 rows. You want the min and the max count.
Oh, okay.
And then you want the invoice ID.
Yeah. Okay. Sure.
The way they did it was like, and the way I thought about it was limiting one and then doing descending and ascending, and you can union it. But is there like a
yes.
cleaner way of doing that?
Yes. Okay. So here, let me. All right. So find the invoice with the minimum number, or we'll just go maximum because minimum is going to be 1. Maximum number of line IDs or something like that, right? Invoice line IDs. Okay. Most elegant, please. Okay. So we'll let me see. You're making me do this on the fly. This is a little bit tricky. Okay. So what we want is so basically, if we have this result, we just want to find the max count, right? So, okay, this is sometimes known as a CTE, okay? And what this does is it's like you create this table as a kind of an intermediary, like this is an important intermediate table first, and then we have to, and then we want to query that intermediate table to get some other results, right? So maybe I'll do group by invoice ID, and we'll do order by count. Okay. Oh. Descending. Okay. We got a bunch with 14. But okay. So we're gonna call this. We call this with. Okay. So you write a with statement. I gotta kind of cheat and look at the example here. So with common table expression. So we're gonna call this. Invoice counts. And let me find a easier example page here. I wear glasses, I don't wear contacts. Okay. All right, so common table with employee CTE, employee number, title. Okay, so we're going to call this invoice counts, and we've got invoice. I'm just going to call it ID and count, and then I write as, and then we put this part in parentheses, the kind of our resulting table in parentheses. And then we do our thing. So we would do so basically it's saying, you know, this is your intermediate table. That's what we have, and it's got invoice ID and count. So we're going to call those ID count, and we're going to select max count. No, shoot. So what did it do? Okay, well let me see if I
Uppercase C.
I don't think that. Here, let me just say select count. Oh, from invoice counts. Okay, so we do this, and we're going to do max of count, okay, which will give me 14, and then maybe we want, so actually, so we'll do select ID count from invoice counts where count equals max of count. Where count equals max count. Oh, it doesn't like that. If I just do count equals 14, it works. Oh, there's a lot.
What if you just do select ID, comma max count? Does that not work?
I don't think so. It'll just give you, it'll give you one of the IDs. Let me see. Can we do a group by? No, that's going to give me everything.
Do select max count as max, and then do where count equals max.
Selects max count as max.
And then where.
So this will give me 14, but then.
Or select count max count as max.
You can't create a variable and operate on it in the same thing, huh?
I think so. You only name columns. That's what the as thing is.
Yeah. Okay. Well, you can get the max count here, okay, using this thing. But so yeah, the CTE, and I'm rusty on this, obviously. CTE, common table expression, is basically allows you to query tables that you created as intermediate steps. So so basically, you know, this table aggregated them, okay, and then and so the result. Okay, so this is kind of an intermediate table that aggregates the counts and you know, aggregates the invoice line IDs, okay, and then you can query that. I don't know if that's kind of what you were hoping for.
Yeah, this doesn't have to take any more time, but
yeah.
I think what they wanted was you have like the whole row of all the different IDs and counts, and they just wanted 2 rows of maximum and min, but here you're creating a new column called max, and then you're putting out the max, but they just wanted the 2 entries that were max and min. If that makes sense. So like, the max and min were rows, not columns.
So the max and min were rows and not columns?
It was just like 2 observations, which is the min and the max of the entire data set. Instead of like creating a new column called max and min and then giving 14 and 1.
Okay, I have to think about this.
Yeah, it's fine.
Okay, sorry. Yeah, but I mean, you can get kind of like create an intermediate table and then query that. But all right, I'll have to think about this other thing. My confession, and I think it's obvious, is I don't use SQL a ton, so I'm kind of quite a bit rusty on a lot of these things. But I think kind of the biggest keys, like if you understand joins, so here I've been just doing inner joins, okay? But I didn't. So the Chinook database is not the best for like left joins and outer joins and whatever, because everything kind of exists in in all the tables. Like they're like you don't have these dangling things where you have an artist in the artist table that doesn't have an album in the album table or something. But maybe I should link to look up, you know, the difference between left and right joins. But I mean, this is left, right, join, Venn diagrams. So these are a visual explanation of SQL joins from 2007, but still good because SQL hasn't really changed much. Okay, so the inner join will only give you the stuff that's in common to both. Okay, and then the full outer join will give you everything together, and then the left join will give you everything in table A that matches also in table B, and then and here you have the left outer join, but if you specify as null, it's gonna take that away and whatnot. Okay, this is stuff that doesn't exist in either. All right, and then you have a right join, and that just depends on the order in which you put the names of the tables. But yeah, this has not changed. SQL's been around for like a long time. And everybody, not everybody, but a lot of places still use it. Okay, so this one was just a whole bunch of tables linked together. So we want purchase track name and artist name with each invoice line item. So we went to the invoice table and we got everything, right? So we got the invoice line ID, and then within the invoice line ID we have the track ID, and so we can get the track name from the track table, and then in order to get the artist name we had to go from the track table to the album table, which we didn't even bother including, and then the album table then links to the artist table. Okay, and so the join statement is quite messy, or in that we start off with the invoice table, we join it to the track table, we join the track table to the album table via album ID, and then we join the album table to the artist table using artist ID. Okay, and so as long as these connections kind of appear, we should be okay. I think these just work as some kind of starting examples. Pretty much, I think SQL is one of those languages or one of those things where you're just going to go online and you're going to type in SQL something, 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 look at some example that somebody else did, and then say, okay, how can I get this to kind of work for me? There's not a ton that are like way too complicated. Probably the common table expressions in terms of like creating an intermediate table in between that you can then query later, and you can even kind of create like a nested version of this where it just gets more and more complex. It can be done. Okay. I don't know. Are there questions or comments regarding SQL? Anything? I'm sorry we couldn't get your direct answer.
Okay.
As far as
I have another one if you want to work through it.
Sure, we can try it.
There's another question that was, if you have like a table of, let's say, all products being sold,
okay,
then you have a sales table. How do you get the products that are in one table that are not in another? So like all the products that weren't sold.
All the products that were not sold. Okay. Yeah, that would be basically the left join where, so you're going to do a left outer join, okay? And the left outer join on the product, okay? So I don't I don't have example table here. So the question is, one table is of products, another table is of sales. Okay, we'll assume product ID is the link between tables. Okay, how do we find all the products that do not exist in the sales table? Is that basically it? Okay, so the answer is you're going to do a left outer join on basically table product table. Okay, so you do you do left product table, left outer join sales table on we'll do product table as P and sales table as S. Okay, and you're going to do P dot product ID equals to S dot product ID, and then you do where S dot product ID. Did I write is null? Something like that. Okay, and that should do it. Okay, so the left outer join will give you everything in the product table and everything that matches in the sales table, but then you say I want just the ones where the sales product ID is null, and that's going to give you everything in one that's not in the other, I think. Here, let me just do left outer join. Left join. Where was the other example? I had this, the visual explanation. So this is what we want. So we basically want this thing, right? So yeah. So select everything from table A, left outer join table B on, and then table A, you link it via that, and then you say where, table B is null or something, where that thing doesn't exist. Okay. Okay, I think that'll do it. Yeah, I don't know. R has a bunch of stuff with dplyr that is kind of based on this language of joins. Probably the joins and becoming comfortable with the joins is I don't know. I imagine what employers are looking for when they talk about SQL stuff, just basic querying things. Okay, I guess we'll wrap up here, and then I'm not sure what to do with Friday. Friday's our last thing. Maybe I'll just spend time about where to go from here in terms of learning more, because there's a lot, right? We only can cover so much in 10 weeks, so maybe I'll try to find resources and point you guys in the right direction for where to go next. Okay, we'll see you guys then.